Today's notes are all about circles. 12-5, circles in the coordinate plane. You're going to set up your notes with about a third of the page at the top with, we're going to talk about how do you find the equation of a circle. And the bottom section is where you're going to be putting in a glue in. You do need a marker or a highlighter, and that's about it. So before you start taking any notes, let me tell you what's going on here. I'm going to talk to you about the equation of a line and the equation of a parabola, but I don't want you to take any notes until I get down to this part, okay? So you're just going to kind of listen and jog your memory. So my first question is, what does a line look like? Well, you might remember that the equation of a line is probably, I bet you probably all remember y equals mx plus b. Maybe some of you remember ax plus by equals c. And some of you might even remember an equation. Maybe your favorite equation was something like this. So those are all lines. And maybe you even remember the equation of a parabola. A parabola is a quadratic function. So it looks kind of like a U. It bends like that, either up or down or sideways or the other way, but it has that curve in it. You might remember that it looks something like this. Ax squared plus bx plus c. And of course it equals y, so it's a function of two variables, an x and a y. We could even say something as simple as y equals 2x squared is a parabola. Really all you need is for the highest x value or y value to be squared or quadratic. So now what if I ask you what's the equation of a circle? What does that look like? Well, let's see if we can derive it. The first thing I want you to put in your notes is what does the equation look like for a circle? And then I'd like you to draw a circle with a center in it. You need to kind of give yourself some space here because we're going to label it. So I'm going to say that this center point, I'm going to name it HK. And I'm going to say, let me change my color here. I want this to be green. I'm going to say that it has a radius that we were going to call R. And I'm going to say that the point that connects the radius to the center is x, y. So basically you have 2 points there. Now I promise you that at the end of this calculations that we're going to do is you will have an equation for the circle, but I'm going to start off with something that's a little bit different. I'm going to ask you, do you remember how to find the distance between 2 points? Do you remember how to do that? It was something, there was an x1 and a y1 and an x2 and a y2. Do you remember how to find the distance between 2 points? All right, well, if you remember, I'm very proud of you. The distance is the square root of the sum of the differences of the x values squared and the y values squared. Now, what if I was specific here? I didn't ask you to find the distance between any 2 points. What if I asked you to find the distance between these 2 points? Well, wait, if you found the distance from this point to this point, that'd be the radius. So what if I just said, hey, find the radius? Okay, well, the radius is the square root. Well, hold on, what are these points? Okay, HK, I'm going to go ahead and say that's this point. So x1 is h, y1 is k. And x2 and x2 and y2, I'm going to say those are x and y. So what I'm going to do is anytime I see x1, I'll substitute an h, x2 will be an x, y1 will be a k, and y2 will be a y. Let's plug in those values. Okay, so x2 is x minus x1 is h squared, y2 is y minus y1 is k squared. Okay, this is okay. All right, bear with me here. What I'm going to do is I'm going to take this equation and I'm going to square it. Okay, that means I'm going to take both sides and square them. Really just for the function of I don't want a square root in my equation. Now, I promise I'm getting to the formula of a circle, but basically the formula of a circle does not have a square root. So if I do this, I'm going to end up with, I think I want to go back to pink now. So I'm going to say the radius squared is, well, anything squared that's square rooted is just itself. So x minus h squared plus y minus k squared. this right here is the equation of a circle. So if you wanted to make a circle, this is how you would do it. Okay, now we're just going to work in your graphic organizer, and I know you already have the equation of a circle written above your notes, but I don't, so I'm going to just kind of repeat that there. And I'm going to zoom in to start off with this table. Now let's take a closer look at it. The first column asks me for the standard form of a circle equation. That's this right here. So they're looking for kind of this complicated equation right here, but instead of having an H, a K, and an R, they're looking for numbers in those places. Information about the circle has something to do with, some information about the circle. That makes sense. And the graph should be a picture of a circle on that graph. That makes sense. Okay, so let's see if we can figure this out. What's been given to us? Just the information about the circle. They gave us the center point, and they gave us the radius. Now, using kind of the code that they gave me up here, I know that instead of writing radius, I could call that R, and that the center point is called HK. That means that H, in this case, is 5, and K is -2. So if I look at this information and I translate it, I know that R is 7, H is 5, and K is -2. So now if I wanted to write the standard form of the circle equation, I could, just plugging in these values. So okay, the first thing I have that I need is the R, and then I'm going to square it. So I have, let's see, 7, and then that value is squared, equals, let's see, x minus something squared. Okay, what's H? H is 5, okay. Okay, then plus y minus, okay, K is -2, quantity squared. Okay, now I have to evaluate this to actually write the whole standard form here. So if I evaluate this, 7 squared is 49, then x minus 5 squared plus y plus 2 squared. That right there is the standard form of the circle equation. Okay, now let's see if we can draw it. Okay, so it's centered around 5, -2. So let's see here. 1, 2, 3, 4, 5, -1, -2. So right, 1, 2, 3, 4, 5, -2. So that's my center point. And there's a radius of 7. So here's what I'm going to do, because we're not very good at drawing circles, but we're going to do our best. I'm going to go to the right 7 from the center. 1, 2, 3, 4, 5, 6, 7. I'm going to make a point right there. Then I'm going to go south from the center. 1, 2, 3, 4, 5, 6, 7. I'm going to go north from the center. 1, 2, 3, 4, 5, 6, 7. And then I'll go, terrible point. Then I'll go left. 1, 2, 3, 4, 5, 6, 7. Okay, now even though you could connect those to make a square, I'm going to try to draw an arc in between each one. Now I know your circles, that it's hard to draw, but something like this is enough for me as long as I can definitively see that your radius is 7 and that your center is at 5, -2. Okay, let's move on to our next problem. All right, here we are now. Okay, for this problem, they've given us the equation, but I need some information, and then I need to draw my picture. So the first thing I need to know is what's going on here. So let me see what I can pull from here. I know that the formula is x minus h squared plus y minus k squared equals the radius squared. I feel like the radius is the easiest here. The radius squared equals 9. So let's see, the radius is a number times itself that equals 9. Oh, it must be 3. Okay. And the center point is going to be HK. Okay, so H, negative H is 2. So H is -2. And negative K is -3. So K is 3. Take a closer look at that so you can kind of gauge what's going on here. I see a positive 2, but I wrote negative 2 here. That's because this is a negative h, and I want to know what the positive h value is. And the same thing's happening here, only in this case these are both negative, so k must be positive. Now for plotting my points, I'm going to start at negative 2, positive 3, 1, 2, 3. So there's my center point. My radius is 3, so I'll go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and draw curves through there. Make my beautiful circle with a clear radius of 3. Okay, not so hard, right? Haha, so you think. All right, let's look at our last problem. For our last problem, they're giving me information about the circle, and here's what they say. The center point is 1, negative 3, and the circle passes through the point 2, 2. Okay, so let's just draw a quick sketch of this. So here's the circle, and its center is at 1, negative 3. I'm at this circle somewhere, crosses the point 2, 2. Okay, let's see if we can get what we need to write the standard form of the equation of the circle. I know that the center is 1, negative 3, and that'll automatically give me my h and my k. But what I'm missing is my radius. How can I find my radius if it's not given to me? Well, they did give me these 2 points, and if I connect those 2 points, it just so happens that it creates the radius. So if only there was a way to find the distance between these 2 points, well then that would give me the radius. The distance between 2 points, oh yes. So let's go ahead and do these calculations over here. The distance is the square root of the sum of the differences of the x values and the y values squared. Okay, so let's look at our 2 points. I've got 1, negative 3 and 2, 2. And I'm going to go ahead and erase. Oh, is this not going to erase? Nope, it's not going to erase. Okay. I have my x1 and y1, my x2 and my y2. And I'm going to put those values into my formula here. Okay, starting with x2 is 2, x1 is 1, y2 is 2, and y1 is negative 3. So let's do our calculations. My distance is the square root of 1 squared plus 5 squared. Now where did it get 5? 2 minus negative 3 is 2 plus 3, or 5 squared. That's going to give me 1 plus 25, or the square root of 26. That means the radius, this distance right here, is the square root of 26. Now, you're probably wondering, how can the radius be a square root? Well, let's put it into the formula and see what happens. The radius squared is the square root of 26 squared. Okay, now I'm just putting it into the formula of a circle. X minus, okay, my h is 1 squared plus y minus, okay, k is negative 3 squared. Okay, let's see if we can evaluate this a little bit. So I'm going to go backwards. This is definitely going to be y plus 3 squared. And this is x minus 1 squared. What is the square root of 26 squared? That's the square root of 26 times the square root of 26. And I could put those all under the same square root. That's one pair. That means it equals 26. This right here is the standard form of that circle. Okay, that doesn't look so bad, but now you're probably wondering, how am I going to graph the radius being the square root of 26? Well, it's definitely a decimal, but we can approximate it. The square root of 26 is really close to the square root of 25. And you know that the square root of 25 is 5. So we're going to say this is about 5, a little bit more than 5. So we're going to draw an approximation of this graph. It's not an exact graph, but close enough. So let's go ahead and graph this. Let's go to our center point, 1, negative 3, and I'm going to go approximately 5 out. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. I'm going to draw my curves in. There's my circle with a radius of the square root of 26. And that's what you need to know about the equations of a circle.